Hello everyone, my name is Prashant Kumar. I pursued my BE Mechanical from Shiv College of Engineering, and here is a similar topic on Nitro Shock Observer. And here is the contents for Nitro Shock Observers. In this introduction, need for shock observers, why gas-filled shock observers, types, advantages, disadvantages, conclusion, and references. And next, coming to introduction part of need for shock observers. Basically, a shock absorber is a hydraulic damping mechanism for controlling spring vibrations, and it controls spring movements in both directions. When the spring is compressed and when it is ended, the amount of resistance needed in each direction determined by the type of vehicle, the type of suspension, the location of the shock absorber in the suspension system, and the position in which it is mounted. Shock absorbers are a critical product that determines an automobile's character not only by improving ride quality and also efficiency, but also by functioning to controlling the altitude and stability of the automobile body. And for a smooth and comfortable ride, the disturbing forces should be eliminated or reduced considerably by using some devices. The shock absorbers are such devices which isolate the vibrations by absorbing some disturbing energy themselves. And telescopic shocks are widely used, which has got the drawback that flow of oil in the cylinder can cause foam of oil and air to form. These limit the optimum throughput of the flow in the valves. Gas shocks represent an advance over traditional shocks. Nitrogen-filled gas shock absorbers are results of years of extensive research and development with the top flight shock design engineers. Nitro shock absorbers are high quality nitrogen filled shocks designed and gas charged specifically for each vehicle applications. And coming to need for shock absorbers, springs alone cannot provide a satisfactorily smooth ride. Therefore, an additional device called shock absorber is used with each spring. Consider the action of coil spring. The spring is under an initial load provided by the weight of the vehicle. This gives the spring is under an initial load provided by the weight of vehicle. This gives the spring an original amount of compression. When the wheel passes over a bump, the spring becomes further compressed. After the bump is passed, the spring attempts to turn its original position. However, it overrides its original position and expands too much. This behavior causes the vehicle frame to be thrown upward. Having expanded too much, the spring attempts to compress that it will return to its original position. But in compressing, it again overrides. In doing this, the wheel may be raised clear of the road and the frame consequently drops. The result is an oscillating motion of the spring that causes the wheel to rebound or bounce up and down several times after a bump is encountered, and control over the vehicle can be lost. And shock absorber prevent these spring oscillations. How shock absorber works? All shock absorbers use hydraulic fluid to convert the energy of the spring to heat. It consists of two strokes, compression and rebound. We'll see in next diagram. Now we can see inside of a shock absorber. In this, the upper mounting is attached to a piston rod. The piston rod is attached to a piston and rebound valve assembly. A rebound chamber is located above the position and a compression chamber below the piston. These chambers are full of hydraulic fluid. A compression intake valve is positioned in the bottom of the cylinder and connected hydraulically to a reserve chamber, also full of hydraulic fluid. The lower mounting is attached to the cylinder tube in which the piston operates. During compression, the movement of the shock absorber causes the piston to move downward with respect to the cylinder tube, transferring fluid from the compression chamber to the bound chamber. This is accomplished by fluid moving through the outer piston hole and unseating the piston intake valve. And during rebound, the pressure in the compression chamber falls below that of their serve chamber. As a result, The compression valve will unseat and allow fluid to flow from a reserve chamber into the compression chamber. At the same time, fluid in their bound chamber will be transferred into the compression chamber through the inner piston holes and their bound valve. And why we need gas-filled shock absorbers? The rapid movement of the fluid between the chambers causes foaming and results in a lag because the piston moves through an air pocket which offers resistance. And third point is foaming results in a decrease of damping and a loss of spring control. And coming to fourth, pressure increases in front of the piston and drops behind it. And fifth one, altogether results in foaming and loss of shock absorber control. And gas-filled shocks. These are designed to reduce foaming of the oil, and construction is similar except the double tube. Here a dividing piston is used. Two chambers, oil and gas. And coming to components, it consists of main components, upper and lower mounts, hydraulic chamber containing hydraulic fluid, gas chamber containing nitrogen at 25 bars, and dividing piston. And we'll see how it works. First, the piston rod is moved into the shock absorber, which displaces the oil. When the piston rod is moved into the shock absorber, oil is displaced as in the double tube principle. And this causes the dividing piston to press on the gas chamber, reducing it in size. With the return of the piston rod, the gas pressure returns the dividing piston to its starting position, while returning the gas pressure returns the dividing piston to its initial position. The pressure decreases behind the working piston cannot be high for the gas to exit from the oil column. So, thus the gas-filled shock absorbers operate without foaming. These are the types of gas-filled shock absorbers. First one is monotube with high pressure and twin tube with a low pressure. And in this diagram, we can see inside of a monotube. These are the main components of monotube shock absorbers. Pressure cylinder, also called housing, a piston connected to a piston rod, and floating piston, also called a separating piston, a piston rod guide, upper and lower attachment. And here is the working of monotube shock absorber. The cylinder is not completely filled with oil. The lower part contains nitrogen at 25 to 30 bar. Here we can see, unlike the bitube damper, the monotube has no reservoir tube. Still, a possibility is needed to store the oil that is displaced by the rod when entering the cylinder. This is achieved by making the oil capacity of cylinder adaptable. Therefore, the cylinder is not completely filled with oil. And therefore, the cylinder is not completely filled with oil. The lower part contains gas under 20 to 30 bar, and gas and oil are separated by floating piston. In this, when the piston rod is pushed in, the floating piston is also forced on the displacement of the piston rod, thus slightly increasing pressure in both gas and oil section. Also, the oil below the piston is forced to flow through the piston. The resistance encountered in this manner generates the bump damping. In the bump stroke, when the piston rod is pushed in, the floating piston is also forced down, slightly increasing pressure in both the sections. Also, the oil below the piston is forced to flow through the piston. This generates the bump damping. In the rebound stroke, when the piston rod is pulled out, the oil between piston and guide is forced to flow through the piston. The resistance incurred in this manner generates the rebound damping. At the same time, part of the piston rod will emerge from the cylinder and the free piston will move upwards. Here we can see another type, twin tube shock absorber. And these are the components of twin tube shock absorbers. Outer tube, also called reservoir tube, an inner tube, also called cylinder, a piston connected to a piston rod, a bottom valve, also called foot valve, and upper and lower attachments. In the bump stroke of twin tube shock absorbers, in this, when the piston rod is pushed in, oil flows without resistance from below the piston through the orifices and the non-return valve to the enlarged volume above the piston. Simultaneously, a quantity of oil is displaced by the volume of rod entering the cylinder. This volume of oil is forced to flow through the bottom valve into the reservoir tube, filled with air 1 bar, nitrogen gas 4 to 8 bar. The resistance encountered by the oil passing through the foot valve generates the bump damping. And this is all about bump stroke in twin tube shock absorbers. In the rebound stroke of twin tube shock absorber, when the piston rod is pulled out, the oil above the piston is pressurized and forced to flow through the piston. The resistance encountered by the oil on passing through the piston generates the rebound damping, and simultaneously some oil flows back without resistance from the reservoir tube through the foot valve to the lower part of the cylinder to compensate for the volume of the piston rod emerging from the cylinder. This is about the rebound stroke. And coming to the advantages of nitro shock absorber. First one is instantaneous response. Because the high pressure eliminates aeration, which is also called foaming, action is always is immediate, and the low mass of gas and the single tube further improves response time. And second one is better fade resistance. Since there is no outer tube, cooling is much better, which gives a drastic reduction in fade, thus more consistent handling and control. And third one is better durability. Single tube construction also allows for a larger internal working area, reducing stress and fatigue for better durability. Decarbon's monodisc valving system features a single moving part that drastically reduces inertia and friction to improve durability and performance. Better cooling of the monotube design results in lower operating temperatures and thus a longer life and efficiency. And fourth one is no need for readjustment. In this, the viscosity of hydraulic fluid changes as temperature changes. This may be because of climate, season, or heavy duty. The high pressure gas compensates immediately and automatically for changes in viscosity. And these are all the advantages of nitro shock absorber. And some of the disadvantages of nitro shock absorbers are the technical requirements for inflation are relatively high, and it is very difficult to repair when damaged. When it is shocked and deformed, it will basically stop working completely. The requirements for oil seals are very high, and the cost is relatively expensive. And some tips before mounting. A stiff suspension does not necessarily mean good handling. Often, the contrary, if a stiff suspension is needed, it should come from the springs. The function of this shock absorber is to dampen oscillations of the spring by converting energy to heat. Do not use shock absorbers to obtain a stiff suspension. Shock absorbers and springs each have their own function. Avoid stiff suspensions. Avoid new shocks to compensate for old and tired springs. One shocks reduce safety and handling. The best advice comes from a mechanic who knows your vehicle. And coming to conclusion, In the current scenario of automobile industry, the need for vehicles which provides smooth and comfort ride is growing. Nitro shock observers are designed to be ultimate in performance comfort. In a country like ours, whose roads are not up to world standards, the need for automatic components like nitro shocks are very necessary. It goes without saying that if the right choice is made, the improvements in vehicles ride and handling can be shocking. And this is all about nitro shock observers. Thank you.